Okay, let's solve this remainder question. The question says, what is the remainder when 2 to the power this enormous term is divided by 11? Now, notice that this 11 is a prime number. And before we specifically deal with this question, let's discuss a point here about divisions by prime number. So, let's say if I have a number of the form n to the power something and is being divided by a prime number p, okay? And here we have n to the power something. Now this n, let's say, is relatively prime to p, which means there are no common factors between n and p apart from 1. Okay, so and the only exception to that is n is not a multiple of p, right? Because if n is multiple of p, then remainder will always be 0 when divided by p. So n and p are relatively primes, which means there's only one common factor between them, which is 1. So basically, what the theorem says is if you have n to the power of p minus 1, p is that same prime number, p minus 1, when this expression n to the power p minus 1 is divided by p, you will get a remainder of 1, okay, by p. Now, this is a very valuable theorem. Let's take an example to understand what we and validate what we are talking about. So let's say we are doing a division by 3, which is a prime number. And here n, let's take as 4, because 4 and 3 are relatively prime. There is only 1, which is a common factor between these two. So what this theorem is saying is that if you raise, so basically if you have 4 to the power of p minus 1, which is 3 minus 1, which is 2, we have 4 to the power 2 divided by 3, the remainder that you will get is 1 by 3, right? And we can validate that. This is using this theorem, but we can validate that easily. So 4 square is 16. 16 divided by 3, the remainder will be 1, okay? All right, now the same can be extrapolated to bigger values of p and bigger values of n to the power p minus 1, and the same will hold. Now, how can we use this in this question at hand? If you look at this question, so if you look at this particular question, we have division by 11. So we have division by 11. 11 is a prime number. So, and on the quotient side, we have 2 to the power, a huge quantity. Now, the good thing about 2 is that it is relatively prime with 11, which means 2 and 11 have just 1 as a common factor. So going by this theorem, 2 to the power p minus 1, so 2 to the power 11 minus 1 is 10. This should yield me a remainder of 1 when divided by 11, okay? This is good. Now, if this is true, if this is true, now relate it back to this expression. This huge expression, if you look at it, is nothing but 2 to the power, whatever is there on the index in the power side is nothing but 10k plus 7, right? Because 7 is the units digit. If you remove that, you're going to get a 0 after 5 here, right? So I can express that as 10k, that entire expression as 10k, and then plus 7 for that unit digit of 7. So this entire stuff, this entire expression can be written as 2 to the power 10k plus 7. It's the same as saying that what is the remainder when we uh, divide this by 11. Now this, obviously this k is a positive integer. Okay, now if you break this 2 to the power 10k and then you break it into the second term, this becomes 2 to the power 7. So there is a product 2 to the power 10k multiplied 2 to the power 7 by 11. We've already seen that 2 to the power 10 from here yields a remainder of 1. And we have 2 to the power 10k. So that will yield a remainder of 1 to the power k. K is a positive integer. So 1 to the power k will also be 1. So this entire expression will yield remainder 1 with 11, right? If that is the case, we are simply left with 2 to the power 7 by 11 as the remainder, right? Now 2 to the power 7, if you look at this, if you can bifurcate this to make it easy, 2 to the power 5 is 32, okay? So 2 to the power 5 is 32. and then you have 2 to the power 2 left, right? And by 11. Now 32 is just one far from the multiple of 11, which is 33. So 32 is at a distance of minus 1 from 33. So we can say that the remainder is minus 1 from here, and 2 square is 4 by 11. So minus 1 multiplied 4 is minus 4. Minus 4 with respect to 11, if you look at on the number system, minus 4 with respect to 11 is plus 7, right? So the remainder with respect to 11 is 7. So the entire expression's remainder with 11 boils down to 7, which is the correct answer, right? Now, this is something that I just went through to explain you. If you are at the top of your game, okay? If you are on top of your game, and this is internalized and you have practiced it, when you see this question for the first time, when you see this question, after this step, you will simply write, you will look at this expression, you will look at this 11, and you know this, you have internalized it, you will simply say 2 to the power 7 by 11. This is what you will directly jump at. And then from here, you know that 2 to the power, you can break it as 2 to the power 5 into 2 to the power 2 or 2 to the power 6 into 2. Either way, you will reach at this answer within 10 seconds maximum, right? So that's the idea. And that's how this T tool is going to be beneficial. Thank you.